Good evening, everyone, and welcome to this AHDB webinar discussing Johne's disease in the suckler herd. My name is Sarah Pick, and I work in the Beef and Lamb Knowledge Exchange team at AHDB. I'm delighted to be joined by Mr. George Caldow, who is Head of Veterinary Services at SRUC. Johne's is a chronic wasting disease which affects an estimated 50% of UK herds. During this webinar, George will discuss how to test for Johne's, how to manage positive cows, sourcing healthy replacement heifers, and also Johne's transmission between cattle and sheep. And of course, George will be answering all of your questions about the disease. So let me quickly remind you how to do this. So if you can't see your question box at the moment, you will need to press the orange arrow button, which essentially is a minimize button. So click on that arrow and it will expand your toolbar options. Then if you click where it says questions and click on the down arrow next to it, you should be able to see where you can type your question in, and remember to press send. I will then read out all of your questions at the end of George's presentation, so please make sure you keep sending those in. Now, this webinar, along with others focusing on suckler production, has been brought to you as part of the AHDB Maternal Matters campaign. Now, this campaign aims to highlight the importance of cow performance in the suckler herd, providing suckler producers like yourself with the knowledge and tools to be able to improve the maternal performance of your herd. And we're focusing on two aspects. That's improving herd fertility and reducing age at first calving. So we've created a website for the campaign, as well as hosting a number of webinars and podcasts like this one. And we also have regular articles in Farmers Weekly as well, so please look out for those. And for further information on the Maternal Matters campaign, visit the website ahdb.org.uk/maternal-matters. So finally, before I hand over to George, I just wanted to remind you that for anyone who has registered for the AHDB Shape the Future vote, voting is now open. So when you registered, you should have received an email which provides you with a link which will take you through to the voting page. So please make sure you take the time to have your say on how your levy is spent. You have until the 9th of May at midday to do this. So without further ado, I'm now going to hand over to George. So George is a qualified vet, with Johne's and BVD being two of his major areas of interest. He is Head of Veterinary Services at SRUC and has a long-standing interest in health in beef herds. So thank you very much for being with us this evening, George. I'm now going to hand over to you.
Okay, thanks very much, Sarah. I hope you can see my slides okay. It's just suddenly come up slightly differently.
Yeah, we can see them fine, George.
Okay. So the first slide is really detailing what we're supposed to be covering. And I think the first point I would make is that one of the objectives was to discuss testing and eradication of Johne's disease on suckler herds. And I think that the really important word there is eradication. And I don't think that eradicating Johne's disease is actually the way that we should be thinking about it. I think it's very difficult to do, and it's very difficult to show that it's been done. So what we are talking about is discussing effective control. And that will be different things for different herds in different situations. It can range from merely ensuring that you no longer have losses from the disease to being able to sell animals that are at the lowest risk of passing on the infection when they move into other herds. So I think that that's a really fundamentally important thing to understand in the presentation. So what do you need to know about Johne's disease? Well, the main thing is that this is a chronic infection. The animals, certainly in cattle, they will have diarrhea and they will waste progressively until the point that they die. There's no real effective treatment. And the worst thing about it is that the peak age incidence for this disease is 3 to 5 years of age, just when you should be getting the maximum return on your investment in these animals. We do see the disease in younger animals, and in some feedlots there can be a surprising amount of Johne's cases, and this is likely to be occurring when the infection level is really high in the herds that they've come from, so that there's been a high rate of infection when there've been calves. The organism that causes the disease is a bacterium, Mycobacterium avium paratuberculosis, and we call it MAP for short. And this organism is a particularly tough organism that can survive in the environment, but it doesn't multiply there. It only multiplies in the cells of the body. It's a disease mainly of ruminants, so cattle, sheep, deer, and goats. But it can also infect other animals, and probably the most important one in that respect is rabbits. Now there was a time before viral hemorrhagic disease in rabbits when rabbit populations on beef and sheep farms were a problem in relation to transmission of Johne's disease, but that's less likely now. And this organism, the MAP organism, is shed from the damaged lining of the intestine into the feces. And in a clinical case, there can be 100 million organisms per gram of feces. That's a lot of infection. And in contrast, the number of organisms in milk and colostrum are minuscule, 2 to 6 organisms per gram. So the important message on this is that while, yes, milk and colostrum and even semen and other things can be infected with the organism, the way the organism is spread is in feces. That's where the bulk of infection lies, and that's where infective doses come from. So feces is the main source of organism for cattle, the environment, and indeed for milk, for when calves are suckling contaminated teats. And if we think about the financial cost, how is it impacting on a herd? So again, come back to this bit about the target productive life of a beef cow is producing 9 calves. And clinical Johne's cases are going to produce easily less than half that in their lifetime. So there's a significant cost straight away from that. And in herds that we've worked with where we've started to work with them before any effective controls been put in place, it's not uncommon to have at least 5 clinical cases per 100 cows per year. And in the year before they develop the disease, they quite often have reduced milk yield, so lower growth rates of the calves, and they often suffer from reduced fertility as well. There's suggestions that, at least in the dairy herd, that these animals have increased susceptibility to other diseases, but there's no evidence that that's actually happening in the beef herd. And another important thing about the infection of Johne's disease is that it can be vertical, that is from the mother to the dam. In the cows that are in the later stages of infection, it can cross the uterine wall, and about 40% of the calves are infected in that situation. And again, calves in general are most susceptible to infection. The risk of the infection from the cow to the calf is lower in the early stages of disease and much higher in the later stages of disease as they start to produce lots of MAP in their feces. So infected cows have a high probability of producing infected calves, and our recommendation is that the cows which test positive, the calves from those cows should not be retained for breeding. and while the cow-to-calf story is clearly important, it's not the only part of the infection chain. If there's enough infection around, any age of animal can become infected. So young stock and adults will become infected from other young stock or other adults from the heavily infected feces. And this is more likely to occur in situations where there is a high level of fecal contamination. And here's an example of some of the situations that you'll see in beef cow herds where there is a high level of fecal contamination over the cow from other cows, and when she's grooming herself, she'll take in lots of infection. So there are other important ways in which infection can spread in the herd. And this is probably also something to recognise, and indeed I think this was probably what people were most worried about 20, 30 years ago with purchase of high value bulls, which were then losing body condition and probably only lasting a couple of seasons when the average breeding life in the herd is 4 years. So the thing I want to go on to now is the weight of infected animals within the herd. And there are many diseases that are referred to as iceberg diseases, and I'll just go through what the concept of this is. It's essentially that the animals that you see with the disease are relatively small in number compared to the number that are actually infected. So the clinical cases are the tip of the iceberg, and below this tip we have another stratum, which is the animals which test blood test positive, and then below that we have the infected animals that are not yet positive. Now, what is important to understand is that we don't know how many of these infected animals are going to progress, or rather even which ones. So we can expect, as I said before, in a herd where the infection isn't controlled, to have about 5 cases per year. But the level of infection within the herd is much, much bigger than that. This basic principle is largely misunderstood. So people do not appreciate how widespread the infection actually is in the herd. And if we can look at a little bit of research here to help explain the situation that we actually see. This is an experiment where they took 30 calves, 10 of which were control calves and don't appear on this, and 20 were infected artificially with Johne's organism. So this is the number of the calves down here. They were kept alive for 5 years and sampled every 2 months. And these red blocks refer to the samples that were positive. So these are dung samples collected. So of the 20 that were infected with the experimental dose, 16 of the 20 became positive, and they shed the organism intermittently in their feces for the first 9 months of life. And then something seems to happen after that, and they stop shedding. And it's only a couple of animals that keep shedding. And when these animals were examined at the end of the project at 5 years of age, they found that at post-mortem examination, 7 of the animals were infected. So they hadn't been shedding, but they were infected. And that's the animals that have the ticks against them there. But these animals that were shedding high numbers of the organism in their feces were the animals that had damage in their intestine. So again, we're seeing that there is a reservoir of infection existing within the herd, and only 1 or 2 which actually go on to develop the disease. So we'll come back to that point of the weight of infection in an infected herd, but we want to consider diagnosis just now. So we've got a number of tests. There are 2 blood tests that are available to us, essentially 2, that are looking at the animal's immunity or immune response to the infection. So we have the antibody ELISA, which is the standard test that's used in all the control programs and the most effective, cost-effective routine diagnostic test available. And then we have the gamma interferon test, which demonstrates the animal's exposure to the infection and the fact that it's fighting it off at the time. The fecal test is looking for MAP in the feces, and there are a number of ways to do that, from simply making a smear of the feces and visualizing the organism. We can culture it. It takes months to be sure that you've got a negative culture. And now the test of choice is the PCR, which is a test for the presence of the genetic markers for that organism in the feces, so the bacterial DNA in the feces. And we also have a test, the phage test, which can be done on white blood cells from the blood. So the ones that are tests that we've got identified in grey there, the gamma interferon and the phage test, are tests that we don't really have a proper understanding as to how we can use those tests in the herd eradication programs or control programs. But we do know that in an infected herd, there are likely to be large numbers that are positive with both of those, and therefore it becomes quite difficult to understand how to use those tests. It's demonstrating infected animals, but it's not telling us which animals are a problem for us in control. And in infected herds, it could be it's not financially viable to use these tests to remove positives, or at least that's the understanding of these tests at the present time. So how do these tests bear up in relation to other tests? It's often said that the tests are poor. My argument is other than that. It's not so much that the tests are poor. The tests do what they're supposed to do, but it's the fact that the disease and the animal's response is quite complex. So if we think about the animal progressing from birth and being infected all the way through to developing the disease at 3 to 5 years of age, we've got this continuum. So what's happening during that period of time? Essentially, if we look at the shedding, and you've seen that from the chart about the experimentally infected animals, we can expect them to be shedding the organism throughout their earlier life and intermittently. And then as they get to the later stages, they shed large numbers. So back to this 100 million organisms per gram of feces. So that's what we get. So if we start to test feces round about here, it's hit or miss. So we will only detect about 10 or 20% of the infected animals by doing this. The next thing is the cell-mediated immunity, so the gamma interferon test. And as I said before, many of these animals are likely to test positive with this, and it's very difficult to understand how to use the test. But what happens is that this wanes, it fades away, and allows the disease to get out of control in the latter stages. And then the next thing is the antibody production. And this is a late phenomenon in the disease. So while the animal's exposed to the organism and should produce antibody, there is something about the immune response that dampens this down. So the animal does not test positive, despite its white blood cells being primed. So what we tend to see is antibody production happening relatively late in the disease. So if we test young animals and up to 2 or 3 years of age, they're quite likely to test negative for antibody in the blood test that we use. But by the time that they're shedding and as they approach it, we should be getting positives. So the ability of the test to pick up the disease at this stage is really good, and the ability to pick up the disease at this stage is almost non-existent. Feces goes somewhere in between. So my contention is there's nothing wrong with the tests. It's just that you have to understand the complexity of the animal's response to the disease before you can use the tests effectively. And so if we look a little bit more at some of the research, and this is really a series of papers which were produced by a group in North America who were looking at control of Johne's disease over some time. So they had a control program which is very similar to the one that we used in this country, the CHECS program that we've been using since 1998. And they felt they had effective control in the herds under study, but they still had 2% of the cows testing positive for antibody in the blood test in the course of their life. But when they followed all the animals up at the abattoir, they found that 20% of the cows were infected. So there were only 2% of the cows testing positive, but there were still plenty of cows infected in a large proportion of the herd. Furthermore, they identified two populations of infected animals. So of those 20% and those 2%, the animals that become positive for antibody produce a big load of infection in their feces. So these animals that are testing positive for antibody are the ones that we have to be worried about. The animals that don't become antibody positive are only shedding small amounts of infection in their feces, so of the infected ones which do not become antibody positive. So these are contributing relatively little to the weight of infection in the herd. So we then get to the situation that these are the animals that we want to identify, these are the animals that we can identify, and by removing them from the herd, we reduce the amount of infection present in the herd. So the control program can only mean reducing the risk of infection. So we remove antibody positives, removes the high risk of infected animals and animals that are likely to lead to infected offspring. And the hygiene program that you put in place within the herd also serves to reduce the spread between animals. And then herds become progressively lower risk of having dangerous animals present. And this is, in effect, what control looks like in the majority of herds. Now, I would say that in the beef herd in Britain, we achieve very much better results than this. So we would look to have most herds testing negative after 5 to 7 years. But what we also have to recognise is while that's achieved, there will still likely be infection present in those herds, but the risk of these difficult animals being present has been hugely reduced. So the national approach to control, what we're trying to do is to improve on the financial aspect. So we're trying to improve efficiency by removing this disease, which is a brake on production efficiency. It's important for the welfare of the animals, important for the financial returns of the producer, and also important in terms of production efficiency and greenhouse gas produced per kilogram of beef produced. There is a theoretical risk of public health risk from Johne's in relation to Crohn's, but that has never been proven, and I honestly don't think that it's an important consideration for beef directly. And we achieve this reduction by reducing the spread of disease between herds. So we have to think about how we're going to do that, and then within the herd, what do we do to reduce the spread of disease? So I'll try to cover both of those aspects. So if we think about how the disease is spread within the herd, and I've explained that the calves are the ones that are most susceptible. The exposure to maternal feces, either their own mother or the mother of other calves in the herd, is what's the critical thing. So we've got contamination of the environment with infected feces from adults. So we all know that to keep calves away from feces is very near impossible. So it's a reduction situation. So we're trying to produce as clean an environment as possible. So I'll go through the things that are important in relation to that. So there's multiple components, and I think that that's also important to understand. There is no one answer, and it's a suite of actions that need to be taken to get the best results. So ways in which to ensure that you've got clean cows and clean calves at the critical period of time, and I'll come on to that in a little bit. And then the test and cull. So identify these positives and remove them from the herd. And in the early stages of the control program, where you may find about 10% of the herd testing positive at least for the first year, if not the second year as well, then you may not test and cull, but test and separate. So you've got to understand how that's going to work. Slurry management, I've already said that this organism is extremely tough in the environment. Even though it doesn't multiply there can be high levels in slurry, and it can survive in slurry for a long time. So there needs to be consideration about how you're going to manage slurry in relation to grazing cattle. And the indications are that the best way of managing that is that grazing cattle do not go on fields which have had slurry on in the same year, but before silage crop has been taken from it. The other aspect of it is water supplies. So where there are water supplies that cattle can dung in and drink from, you're going to get a spread of infection there too. And then finally, we've got sheep and wildlife. So sheep are a reservoir of infection for cattle. They'll become infected with the cattle strains of the Johne's organism, and they will contaminate the pasture and lead to new infections in the cattle, even in herds where there are real efforts being made to remove positives through test and cull. And if I can just say a little bit about the colour gradation here, that's supposed to indicate what's most important. So we've got test and cull, and clean cows and clean calves are the most important elements. The slurry management, water supplies are the next level of importance, and sheep and wildlife are the lowest in relation to this control program in terms of focus of management. So the other considerations, and I think this has come forward in a lot of our problems herds, is that the calves at foot should be housed for as short as time as possible, and that's whether they're spring, late summer, or autumn calving. Some of the worst problems that we've had to deal with have been where there have been autumn calving cows, and the cows and calves are housed for several months. The next thing is a tight calving pattern. A tight calving pattern works for so many different aspects of promoting health in calves in the cow herd and increasing efficiency of production, but it's really vital for Johne's disease. The disease is most difficult to control in herds with prolonged calving patterns where calves are inside with cows for several months. And so this last bullet point is something that you should be thinking about and saying, if your herd conforms to that, then you should be finding ways to change that, because that's vital in terms of managing the control of this disease. So that's the within herd control, and clearly there's a lot to it. And what I would say about that is that the way to achieve the effective within herd control is to sit down with your vet and carry out a Johne's health plan. The Czech's Johne's disease control program has the health plan at its heart, and all herds that have a risk level have a health plan in place, but it applies to every herd that's rearing calves. They should have a Johne's health plan in place. And in terms of reducing the spread between herds, what we would want to do is to identify low-risk herds and be able to flag that up at the point of sale. And that's essentially what the Czech's Johne's disease control program does. So it's periodic testing supported by the health plan, and it's based on the concept of picking up these antibody positives and stopping them causing a great deal of contamination in the herd. And our advice is to remove test positives and their last two calves, and that refers to the cows. While bulls can be infected, or clearly are infected, everybody will have experience of that, but they will produce the organism in their semen, but the risk of that creating new infections in either the cows or the calves that are born from those matings is negligible or not important for practical control purposes. So it's not something that you should be worrying about. And how do we see the progress going? Well, in my experience, we get rapid progress from infected herd to clear herd in a few herds. It's not the standard situation. But what we do see is an effective reduction in clinical disease very, very quickly. So within 2 years, clinical disease is largely a thing of the past. And then the number of test positives is also reduced to zero over 5 to 7 years. So in herds with a high initial level of infection, progress is slow, but I would go further than that now, and I would say that where progress is slow is where people do not put in place the control program and do not adhere to the control program. And that's essentially what I'm saying with that last bullet point. It's keeping the discipline, and I suppose that's one of the real challenging aspects of Johne's disease is control. Is that for many diseases you can put in place a control program, and the problem is largely mitigated. Excuse me. But for Johne's disease, what we're talking about is a control program that has got to be kept going for years, and that there is a real communication problem to ensure that the stock, the people working with the stock, are aware of that year after year after year. And I just want to, this is a really old slide, I've got this next slide, but for me it was an important one. It was the records are from a client of ours who was really quite dubious about what could be done about Johne's disease. He had a herd that was restocked after foot and mouth disease, and he restocked from multiple sources, and in the years immediately after restocking had a big clinical problem with Johne's disease, and we then got involved. And so this is what we saw after we started testing in 2004. So he was testing about 130 to 150 animals per year, and he adhered to the control program to the letter and kept the cows as clean as possible. So in 2004 there were 5 positives and a couple of inconclusives, and our advice is to be harsh on the inconclusives as well as the positives. And then this fell quite quickly to the situation that after 5 years he was testing clear, and that herd has gone on to maintain risk level 1 since that period of time. So the program worked in a challenging situation, and it worked because not only is the science behind the disease control program robust, but the people that were putting in place the control program at the farm level understood absolutely what they should be doing and stuck to it. And this is a slide that I used to use a lot with commercial producers who had problems with Johne's disease, and trying to understand how the control program can be cost effective. So essentially, modest price of cull cows, £1,000. I dare say that's much more than that these days. Poorer thin cows, so cows that you pick up as scouring and decide to cull from the herd at that point, you might get £300. And if the animal dies on the farm, then you've got the cost of an uplift of a carcass of about £150. So if you think about that, the price differential in this is from £700 to £1,150 that can be lost if there's no action taken on Johne's disease. But if you're doing a test and cull, you're identifying these animals before they get to that stage, and therefore you are able to achieve good prices on cull cows, and the control program is probably not costing you any more than £800 to £1,000 per 100 cow herd anyway. So in a commercial situation, a herd with Johne's disease is likely to see a strong positive cost benefit for a control program. And it's important, as I said before, to make the testing program work. So manage your herd to maintain a tight calving pattern, test the herd at 2 to 4 months before calving to remove the positives sufficiently early to allow cows to clean up. And the test positive cows, well, what we found with these is that if you separate them from the herd and treat them preferentially, that the chance of them progressing to develop the clinical signs of Johne's disease is reduced. So it's quite possible for most of these to rear their calves during this period of time, and clearly all calves from these should be finished. The cows should have their body condition monitored closely, and if there is any sign that they're losing body condition, they should be sent for slaughter, and they should be sent for slaughter as soon as the calves are weaned. Now that's straightforward enough in the early stages of the control program, where you might have a handful of cows to maintain separately as a group, but in a successful program, the number of test positives are going to fall quickly, and you may in fact get very little benefit from excuse me, from keeping this as a separate group. It might be more cost effective and simpler for your management simply to cull those. And it's important then to make sure that your testing is done sufficiently in advance of calving so that you're not presenting heavily pregnant animals for slaughter. So in terms of developing a strategy, this is just some broad guidelines. If you believe your herd is free from Johne's disease and you're rearing your own replacements, then all you should be doing is testing any suspicious animals, any thin animals, any animals which have not held to the bull for Johne's disease on an annual basis, and just satisfy yourself that Johne's disease is not present. And that would be by the blood test and the feces for backup if required. If you're selling breeding stock, simple, straightforward solution is to join the CHECKS accreditation program, define the risk level of your cattle and start to get value from being free from Johne's disease. If you're finishing all stock, which means you're buying replacement females, then you want to have the same approach about monitoring suspicious animals. And if you have positives, there'll be a high probability that you've bought them as positive, and therefore you should review where you're buying your animals from. If you know your herd has Johne's disease, then it's a different situation. You're moving into the management program, test and cull, and on the basis that you're going to reduce the rate of infection in the herd and reduce the clinical disease in a cost-effective manner. And this is the CHECKS risk levels. So the value of this is that if you're buying breeding animals, by sourcing animals at risk level 1, you're buying animals that have the lowest risk of introducing infection to your herd or from going down with the disease in the course of them being in your herd. Risk level 5 is essentially herds which are not following the CHECKS program. They may not have Johne's disease, but they're doing nothing to stop it, and they're doing nothing to show you what status their herd is. So you can assume that they carry with them the highest risk of Johne's disease. Risk level 4 is where there is a health plan in place, and at the last herd test, there was more than 3% of the herd testing positive. And in these situations, there is a moderate to high risk of Johne's disease when you purchase cattle from a risk level 4 herd. Risk level 3 is as for risk level 4, so there's a health plan in place, and there are 3% of fewer of the herd testing positive, so a moderate risk. So it's a descending risk of the presence of disease. Risk level 2 is for herds that have achieved a clear test and have a health plan in place, and these are low risk, but it's risk level 1, which is the best option for purchase. These have had at least 3 consecutive annual clear tests, and it's a little bit like how EBVs can be moderated with time. The longer the herd has had risk level 1, the lower is the risk. So a herd that's had risk level 1 for 5 years is lower risk than a herd that has just recently gained it. And on the certificates, it says how many years the herd has been at risk level 1. The next thing up is the size of the herd. So the larger the herd, that's testing free, you can have more confidence in the absence of infection in that herd, and that's the lowest risk. So go for larger herds that have been testing for some time. And one of the things that's almost difficult to impossible to assess when you're buying cattle is what the breeder's attitude to adding animals has been. Because if a breeder is buying from multiple sources continually, then there is a higher risk than if they are more self-contained and bringing genetics into the herd through artificial insemination or embryo transfer. So this information is available at the point of purchase of all bulls, but in pedigree sales. But in order to really make a difference overall nationally, what needs to happen is that the same approach that's been taken by the breeders of terminal sires needs to be taken by breeders of maternal stock as well. And it would be great if we could get to a position where, as for bulls, when you go for a sale to purchase replacement heifers, you have a large pool of risk level 1 animals for sale. And if we get to that position, then we can expect to have an effective reduction in the transmission of disease from one herd to another. And then the final thing that I wanted to cover was the risk of infection from sheep. An infected herd that co-grazes sheep and cattle together is unlikely to get free of Johne's disease. If you have the sheep become infected from cattle and continue to be a source of infection to the cattle. So sheep are what we call a reservoir of infection for the cattle. And I would recommend that where you have co-grazing systems, that you monitor the situation in cull ewes, and every year examine a proportion of thin cull ewes. So select animals that aren't thin because they've got bad teeth or are lame, and screen them for Johne's disease and look further for diseases like MID-VISNA and OPA, and make sure you recognise what's present in your flock. But as long as you're co-grazing, there is a risk of infection in that situation. And I just want to end, I think this is just about my last slide, go back to this iceberg disease concept. So we've got the few clinical cases, the blood test positive, and the big weight of infected animals in the herd. So that's in a herd where there's no control going. So if we think about the herd that has a control program in place, this is the situation that we should be getting to. There are no clinical cases, there are no antibody positives, and the number of infected animals in the herd will progressively reduce to negligible levels. So Johne's disease is an important cause of loss and inefficiency. There are multiple reasons why it should be controlled. The control has lots of parts and can't be achieved in a few years. And I would say that there's a control strategy suitable for every beef cow herd. And don't forget the herd health plan. It's not simply about blood testing. There's more to it than that. So that's all I wanted to say.
Brilliant. Thank you very much, George. That was really interesting. Please do keep sending your questions in, and I'll make sure I ask George them. So the first question is, can colostrum carry Johne's? I'm just thinking suckler herds may go and get colostrum from a neighbouring dairy farmer. Can they get Johne's through that?
Yes, they can. And if to go back to the numbers on one of the slides, you know, there's 100 million organisms per gram of feces from an infected cow, and 2 organisms per mil of milk. So a mil of milk is roughly equivalent to a gram of feces. So the milk in the colostrum is not a problem itself, but the hygienic collection of colostrum is a problem. And the pasteurization systems that some dairies will have in place to manage control will be an effective way of reducing the weight of infection in the milk and colostrum. But the real important thing is to ensure that the udder and teats are as clean as possible when the colostrum is actually collected. I don't think it's good practice to take colostrum from other herds, full stop, for multiple different reasons, no matter how it is actually done. I don't think it should be done.
Yeah, thanks, George. So the next question is, if my cattle are drinking from a herd upstream who may have and there may be a positive, sorry, I'll repeat that again. So if cattle are drinking water from the stream and there's a herd with positive Johne's cattle further upstream, can those cows drinking water downstream get Johne's?
Yes is the answer to that. And there was a really interesting study done many years ago in the south of England where it was focused on dairy cows, and they got effective control simply by ensuring that all cattle had mains water supplied to them, so that they stopped the supply of water from other contamination. So it's important for within herd transmission, but it's also important in the situation that you've just described to me there, where infection is coming downstream. And of course, other infections can be spread that way too.
That's it. So there's lots of questions coming in now. Can I carry the disease on my boots from one farm to another?
Yes, it's not a very likely way that the disease will be transmitted, though. But I'm not going to sit here and say you don't have to have clean boots going from one farm to another, because you do. Diseases like salmonella are going to be spread in that way, where a smaller infective dose is required. But for Johne's disease, that's insignificant.
Right, brilliant. How typically do sheep pass Johne's to cattle?
They do. Clearly they do. We know that. We know from observations in terms of looking at herds that had difficulty to control the disease, and we found it in quite a high level in the sheep. About 10% of the sheep were infected when we looked. So it behaves rather similarly in the sheep herd as it does in the cattle herd. It's just that people don't recognise it in the sheep flock, because they don't tend to scour so much. So while they can produce loose feces, they're not often scouring. I mean, we do see odd Johne's cases in sheep that scour, but mostly they don't. So you might think that because they're not scouring, there might be less infection spread about from the sheep, but in practice, they are a potent source of infection.
Okay, great. So there's another question on this. So how do you define co-grazing of cattle and sheep? Is it totally together, alternate grazings, alternate years? So how far apart do those grazings need to be?
And that is a really good question, a critical one in relation to understanding what you can and can't do. Essentially, the organism is going to survive on the pasture for 6 months. High sunlight levels, high rainfall causing the feces to leach, to break up and leach in, are all going to break down and reduce that risk. But you would usually want to have a grazing season apart. So sheep 1 year, cattle the next. Designed in with a clean grazing system or something like that is where you're going. Now I understand completely that there are production efficiencies gained from closer management of pasture with cattle and sheep, but there are risks that go with that. So it's once you start to bring them closer, like cattle following sheep to clean up pastures, etc., you start to get into difficulties with infection being present on the pasture for the cattle.
Brilliant. So there's a lot of questions now. They're all flooded in. I'm struggling to keep up with them. So next one, you refer to test positive. Do you mean blood test positive or feces positive?
In the control program, It's blood test positive, and
Okay.
if you're wanting to get on top of the disease, blood test positive should be removed.
Right. And another question on this. I test for Ionis every year and do not cull blood test positive, but feces negative. Am I right?
In my opinion, no, and
Okay.
I'll tell you why that is some of these antibody positives will shed the organism intermittently. So I don't know if you remember the diagram I put up. If you think about the middle bit of the lifespan of an infected animal, sometimes they're positive occasionally for blood and feces, but they doesn't necessarily match up. The ability to pick up infection on the feces is probably about 30%. So if you get a blood test positive in a herd that you know is infected, you should not rule out infection by saying it's feces negative. You may just have missed it on that day. So the
Right.
safest thing to do is to remove those antibody positives in that situation.
Okay. Brilliant. Now, I think this question might have come from a vet. So they've put very nice and concise presentation. Thank you. Are calves vertically infected, developing effective immune response? So cell mediated early life as well? If so, will the disease be clinically seen later on in their life?
I don't know of any work that's been done round about that to differentiate the immune response of calves that have been infected in different ways. So
Okay.
I can't say that, but the accepted wisdom is that offspring from infected dams should be seen as high risk of becoming these animals which are antibody positive and shedding large amounts of the organism.
Right. Now this question's really a really good one. So with the price of fertiliser, I'm getting pressure to spread farmyard manure on grass, as I stopped when I joined checks. So how long would you have to store farmyard manure before spreading on silage and grazing ground? That's a very good question.
Yeah, and it's these things which really are taxing in terms of putting the program together and having confidence that you're doing the right things. Well, firstly, I would say if it is actually manure, so that it's heated and so it's a straw-based system, the heating that goes on in as the feces and straw breaks down kills almost all pathogens, including Ionis disease. So I'm not saying that it's sanitized, but it really does reduce the rate of infection. So proper composting goes a long way to help you manage that situation. The situation with slurry is very difficult, and injection systems are one way to reduce the amount of contamination. And as I said before, taking a silage crop off rather than letting the cows graze is probably also better, on the assumption that a lot of the contamination will be washed off on the herbage, and that there is the possibility that the whole process of silaging reduces the rate of infection too, and siling reduces the rate of infection as well.
Okay, brilliant, thank you. So another question, we are advised by a vet not to worry about blood testing animals before 2 years of age, as the blood test would be inconclusive. Would you agree?
Yes, there are very few animals that test positive by the blood test before 2 years of age. And in some control programs, I think notably the Dutch dairy program, when they started off, they didn't test any animals below 3 years of age. Our experience, however, would be that it's worth testing them in 2 to 3 years of age as well. But going earlier than that, it's rare that we see positives. It gives us a dilemma around about added animals, because we require in the program added animals to be tested if they're not from a risk level 1 herd. But we know that the probability of them being positive on the blood test is really low. But you've seen from some of the data that I've presented that the possibility of picking up in the feces is higher, irrespective of the age of the calf. So I think that's the situation. So what's being done in that herd is what I would advise as well.
Okay, Brilliant. So the next question, I've been testing and culling 300 cows for 5 years, but keep getting positives as buying in dairy cross replacements.
Yeah.
So the last 10 came last June. 4 were positive at December's herd test. So as keeping replacements on farm from now on, how do I go to risk level 4?
Okay, I think that the main point of that question, I think, is round about what is a sensible policy where you are buying animals which fit your system from the dairy herd, but are carrying a high risk of Johne's disease. I think that's
I think that's it. Yes,
that's
George.
it. So I think that risk is going to be maintained, and probably the only way is to monitor your sources. So if you're consistently buying from the one or two sources, then you should be able to see what is the highest infected ones and stop sourcing from there. But then if what you're doing is buying the best price cattle at sale, then it really is a case of buyer beware. And the only way that you can progress with that is to keep doing the testing and culling on the basis that, as I put forward, that makes sense to remove animals in good body condition that are test positive, as opposed to trying to do something with them once they've started to lose body condition. So it's a really difficult one, and there are plenty herds, dairy herds, testing for Johne's disease, and within that there will be some which have probably got quite a good status, but they may not be the ones that are selling beef cross animals for breeding.
Right. Okay. So this, the next question is asking about TB testing and Johne's testing.
Mm-hmm.
Is there any relationship between the two?
Yes, there is, and it's
Okay.
quite fascinating, really. We don't know all the details on this. This is just unraveling more and more with more bits and pieces of research being done. But if we just think about TB in the first instance, there's quite a good blood test for antibody for TB, and it's used in many different species. And what we find is that the animals that are infected with TB will test positive in the blood test of TB if you take the blood test 3 to 4 weeks after they've been TB tested in the skin test. So the skin test does something to change the immune response of the animal. And I said before about the suppression of the antibody production that goes on. It does something to change that and allow the antibody production to get up to the level of detection. So we know that happens for TB. And it's a principle that's used in can be used in cattle. It's used in camelids, etc. So we know that works. Now the same thing appears to happen in Johne's disease as well. So after TB testing, you will see more positives in an infected herd, and they were previously thought to be false positives, but what we found, and we've done this examination on our risk level 1 herds, what we found is that there is not an increased chance of herds in frequent TB areas of the TB testing areas of the country having more positives than in herds that are in Scotland that's officially TB free. So
Okay.
we are convinced that what is happening, as I said, is that the intradermal injection of the TB test alters the immune response and allows animals that are infected to show that by producing an antibody response for a transient period of time after the TB test.
Okay, thanks, George. No, so I know it's 8 o'clock, so I'll just ask 2 more questions. So the first one of the 2 is, what's the herd control program where you have a high level of positive blood tests? So they're having 2 clinical cases per year, but 65 positive blood tests from 240 cows. Is this a typical example?
No, No, it's not a
Right.
typical it's an extremely unusual picture to see, and I think there's something going on there which is not straightforward, and I can't offer anything glib to say at this time. That would be a case of looking more closely at that particular herd to try and understand
Yeah.
what's going on.
Yeah, and then working with their vet.
Yeah.
So the final question is, what is the current checks debate about the allowable percentage of blood tests positive in setting risk levels?
Yeah, well, it's complex, and it relates to this. I think the fundamental thing is that people don't believe the number of infected animals that are present in a herd. And when they get a blood test, they expect it to be a false positive if it's feces negative. And there are some situations where people are really retaining these positives and are being told by advisors that they don't have infection in the herd. And so that's one school of thought, whereas the other school of thought is that the blood test is extremely accurate, and the fact that you're feces negative doesn't mean that animal's not infected. And essentially, it's round about that. So if you use a feces test which won't detect all positives to negate a positive blood test, you're actually confusing the situation. And that's my belief, is that you need to be harder on this disease, and you should not be imagining that these are false positives, but they're telling you, they're giving you a true picture of the infection in your herd. And always remember that pyramid of infection. Always remember that the animals that test positive are a small proportion of the truly infected animals in your herd. So I think that's the essence of the debate. It's a debate that's not been resolved yet, and it's created an ongoing discussion which has people with fairly extreme positions on it. But I hope that's my position,
Yeah.
which I think is borne out by the science, dare I say it. But then I wouldn't I?
Brilliant. Thank you ever so much, George. That has been a really interesting presentation, and it certainly generated a huge amount of questions. So thank you to everybody who has sent those questions in. So I'll bring the webinar to a close. I'm sorry I've run over a couple of minutes, but huge thank you for being with us tonight, George. That's been a really interesting and thought-provoking presentation. I'd like to also thank my colleague Bryony, who has been working behind the scenes to ensure that we didn't have any technical glitches this evening. And finally, a big thank you to everybody who has been listening. I really hope you have enjoyed the conversation. When the webinar ends, you'll be taken to a survey. Please, if you can, provide us with some feedback. It really helps us tailor these events. If you'd like us to discuss any other topics, please do put them on there, and I'll do my best to organise those for you. So thank you again, and have a lovely evening.